In this video, we're going to talk about some of the content from chapter 3, which is and we're going to talk about primitive data types and some of the arithmetic operators for doing addition, subtraction, multiplication, and division. We've already talked a little bit about some of the numeric data types. We've been using int. We've also been using double. So int, these are the integer data types. Integers are whole numbers. 1, 2, 3, 4 are integer numbers, for example. Numbers that have decimal precision, 1.5, those are not integers. Those would be float or double values. So in this case, we actually have 4 different data types that can be used for integers. We are really going to use int. We'll cover just about everything we do in this class. The only exception is for phone numbers, we will actually use the long data type. But int and long, frankly, they are, in this class will be interchangeable. If you use long as a rule, it will always hold, a long data type will always hold everything that an int data type can have, but an int data type will not hold everything that a long data type can have. So int and long, that's what we're going to be using. My habit is I tend to choose the smaller data type when I need it, and then only use the longer data type, the long value, if I'm actually going to be using numbers that are that big. So up to you, int or long, either one will get you through most of this class. We have 2 data types, float and double. I'm using the double data type. I think it's just easier in my brain, it just works better. So I use double. Float, this is similar to int and long. Between float and double, it's really the value, the length of the numbers that you can put in them. So I'll be using double for everything in this class, and I would encourage you to do the same. We also have some character data types. We've talked about string data type a little bit. String is actually not a primitive data type. It's actually a class that's built into Java that has some built-in methods and other functionality that we'll see in upcoming weeks. But there's also a char data type. This represents a single character. So a char data type would, for instance, hold a single lowercase a, a single uppercase b, things like that. That would be the limit of what it could hold. It also is used to represent some of the special Unicode characters. So you can represent a new line or a tab character, things like that, using the char data type. Then there's also Boolean. Boolean is a data type that just returns true or false. So Boolean is either true or the Boolean is false. We use this for conditions, for the if statements, switch statements, while loops, for loops, things like that. We use a Boolean expression and a Boolean data type to be able to control flow of the program. So we'll be seeing those when we start talking about if statements and switch statements. This is the assignment operator equal. We use this already in the class. This is how you assign a value to a variable using the assignment, a single equal symbol. You can assign literal values. So if I say, int x equals 1, then that 1 is a literal value. And so I can code those. Java is pretty good about inferring what kind of data the literal is. But if you're using just int or double, then you really don't have to do anything with the literal. If you're using float, long, or these other data types, you actually have to mark the literal when you put it in. So with these, this won't really come up much, but just know that literals have an implicit data type, and so sometimes you need to be aware of those. This is declaring and initializing variables. We've already done this in week 1, so I'm not going to dwell on this. We also have type inference. We've been defining variables. In this case, we would say int counter equals 1. You can also use the var data type here. If you want to use that, then that will Java will infer the type of counter based on the type of the data on the right side of the assignment statement. So in this case, the right side of the assignment statement, this is an equal sign. The right side of the assignment is 1. So that to Java, that looks like an integer value, an int data type. And so when if you use this statement, the compiler will define counter as an int data type. Similarly, this will be a double, unit price 14.95. And then you see here, we're decorating the literals using the float and long data types and so forth. So you can get the idea here. Using var is a fine practice, and most experienced developers will use it extensively. I will say as a beginner, it can get you in trouble if you make a mistake on the right-hand side of the expression. If you intend to have an integer value, but yet you are put in an expression that might yield a double, you'll get the wrong data type inferred. And so sometimes that can lead to logical errors in your program. I would encourage you at the beginning to stick with explicit definitions. And then as you get more experience and move on into more and more complex programs, you can switch over to the implicit, to the type inference. Okay, constants are a special type of variable in that they once you define it and assign it to a value, it doesn't ever change, and so you cannot change it. And so we define a constant using a final data keyword. You give it a type, just like anything else, just like any other variable. Then we typically name constants uppercase with underscores between the words. And so days in November, for example, sales underscore tax, final float sales underscore tax 0.075. I would have done this as a double, but if you want to create things like tax rates, days and months, the value of pi, whatever those constants are, things that will never change, you can use a final to do that, to declare a variable that has that data. These are the operators. We've already seen these: plus, minus, multiplication, division. Modulus is an operator that yields the remainder of a division. So if you say 3 mod 2, 3 divided by 2 is going to be 1 point something, you would actually get the remainder in this case, which would be 1. So we use modulus to define to get the remainder. In this course, we typically use modulus to determine if a value is even or odd. That's typically what we do. If you take a value, you mod it by 2. If the answer is 1, then the value is odd. If you take that value and mod it by 2 and the answer is even, then the value is even. Or the answer is 0, then the value is even. Here we have, you see we get, this is going into our type inference a little bit. Well, it's going into our not type inference. This is examples of arithmetic expressions. We've already seen these. I'm not going to dwell on these. We have some shortcuts for arithmetic operators. You can do plus equal, minus equal. So if you are just accumulating data into a single variable, then you can use these shorthands. Here's some examples of those. Count equals count plus 1. You can write this also as count plus equals 1. So if you're just trying to increase the value, or you're just trying to add numbers into an accumulator, in this case, count and total, these are accumulators. We're just adding things up and summing things up. So in that case, you don't have to. You can write this out: count equals count plus 1. You can also write it like this: count plus equals 1. This just saves a little bit of typing, and is pretty straightforward. In this case, with 1, you can also do count plus plus, which will yield a here it is right here, which will yield just an increment of 1. There's an incrementer, a decrementer, and then you can also change the positive or negative value of a variable. So in this case, int count equals 1, count plus plus. This is the same as count equals count plus 1, or count plus equals 1. Count plus plus just adds 1 to the value of the variable count. You can also do it with a negative, with a subtraction, with using the decrement operator. Okay. There is an order of precedence in the arithmetic operations. This follows what you've learned in your math classes. You can control these using parentheses. So anything that's inside parentheses is executed according to the order of precedence for arithmetic operations, etc. So the order of precedence in Java is just like the order of precedence in any math equation anywhere else. Okay, here's some more math examples. I'm not gonna stay on those. We've already seen them. We also have occasionally we'll need to change the data type, or we'll want to use different types of data in the same expression. And so when you do that, you have to be cautious about when you're doing implicit or explicit casts. Cast is when we're taking a value and we're changing it into a different data type. So you can see here we've defined a double. Here we've defined some ints. When we do math on these things, we're going to be implicitly casting these I and j values into other values. And so you need to be cautious when you are doing math using mixed data type, that you understand what the data types of all your values are and what the data type is that you want it to be in the end, to make sure that you don't get rounding errors. Also, a widening conversion, anytime you cast from int to long, for example, every int value can be held in a long value, so you can always cast up. The same with float to double, int to double. All of these are all widening conversions. They're upward conversions, and so they will always work. If you are doing a narrowing conversion, if you're casting the other direction from a double into an int or a long into an int, for example, sometimes those won't work if you're overflowing the capacity of the receiving variable. And so in that case, you would get an error in your program, or you would need to take steps to accommodate that, to make sure that your program doesn't fail. There are explicit casts here, so you can say what type you want. In this case, grade. For example, if I want to convert this, I can do an int in parentheses, and give it the literal value. This will actually convert int, the 93.75 double literal value, into an int data type. And it just does a truncation. It is not a rounding conversion, it's just a truncating conversion. Okay, so truncate means we just chop off the decimal points and we're left with 93. So if you want to round it, you have to do a little extra work here. Here's more examples of casting. We have a math class. You can use this to do the rounding and also do powers, minimum, maximum, random number generations, things like that. So math is a class that's built in just like the scanner, just like the string class, things like that. So you can use these. You have to include java.lang.math in your programs, and then you can use round functions, power, square roots, things like that. So here's an example of the round function. If you want to round, you can round something. So in this case, if you wanted to round that grade to the nearest integer, or round this number to the nearest integer, you can use math.round to do that. If you want to round to decimal points, you have to do a little extra math in order to do that. Math.round is always going to return an integer value. So you can, in this case, what we're doing is we're rounding. We're multiplying the number by 100. We then do the round, and then we divide by 100, and so we actually round to 2 different decimal positions. So just a little slightly extra step there if you want to round to decimal precision. Often when we're doing presentation work and we want to print information or put information onto a user interface, we don't necessarily have to round. We can use formatting functions, which we're going to talk about here in just a minute, to actually format the data that we want to print. So rather than taking 10.315 and actually changing the value of this variable, we would just round it using a formatting function when we print it out to the console. Either way works. It really just depends on the intent of the program. Here's using powers, math.pow. Here's the square root method. These are really just here for your knowledge. Min and max, these only take 2 values, min and max. You can also get min and max of lists. When we start talking about lists and arrays, we'll see other min and max functions that come in there. Math.random, math.random generates a random number between 0 and 1. And so you can, if you are trying to calculate a random number, say you're writing a program that simulates the rolling of a set of dice, then you can use the math.random function to calculate those. Here we have formatting classes. I'm going to skip over these for now. We're not going to use these in this week. When we do come back, when we do use these, I'm going to come back and talk more about them. But typically, you get use the number format class if you want to format a number using currency or percents. You can also use it using the number instance to round. These are really just, you use the formatting class when you want to take a numeric value, when you want to format it so that it can be sent to a user interface of some kind in a human readable method. The currency and the percent also, the number instance, these also use the locale setting. So, the way that the currency symbol that we use in the United States is the US dollar symbol, but in the European Union, they're going to use a euro symbol. In China, they would use their currency symbol. So those are based on locale. There's also differences in the way that we use periods and commas to define numbers throughout the world. And so whenever you use these currency and percent instances and number instances, these formatting, you can tell it what locale you want to format it in. In our case, if you don't give it a locale, it will just take the default one from your computer. And in our case, that will get the US formatting. So just be aware of these. We're going to come back and talk more about these later. This is the formatting that we're going to use most often. It is a much simpler method for formatting numbers called printf. This is in some languages, this would be called string interpolation, where basically we can use this printf command. So instead of system.println or system.print, we would use system.printf, and then we would system.out.printf, and then we can give a formatting string, and then we can provide arguments. So we can create a string that includes some literal string values. Maybe the answer is : and then a number from a variable that we then can format to a certain number of decimal places or thousands, delimiters, things like that. So we'll be using this in the week 2 assignment. So we'll have some experience with that. Here are the formatting codes that you can use. And we're going to see examples of this in a minute. You can format a decimal, a floating point, strings, uppercase, and then you can, of course, do a new line. There's also a tab function that you can put in here, which is a T. You can add 1,000 separator. Here's some examples of the interpolation that's going on. So we have a string named Joel, it's called name. It has a value of Joel. We have an int called age, which has a value of 39. We can do the system.out.printf, and we can say %s. This is the replacement value in the format argument. We can say %s is %d years old, and then %n. And so this is the first replacement value in the format. And so we will come now to the list of arguments at the end. We get common name. This value name will be replaced into this %s. This value age is the second argument. So we'll go into the second replacement value %d. And so now name will be interpreted as a string, and we'll go here. %d will be, this is age. So it's going to be a numeric value. %d being the integer value. Remember here that we saw decimal integer versus floating point. Okay. So and you can also put formatting codes onto the numeric data type. So we can see, for example, we have this % comma 0.2f. This means that we have a floating point number. We want so this is %. So the % means this is a replacement value. We have f means it's a floating point number, and will be price 1. We say we want the comma means we want thousands separator, and the 0.2 means we want 2 decimal points. So if price 1 looks like this, 99.99, it's going to print out just like that. If we had 0.1 on here, then we would only have it would have rounded this value when we print it out. Okay, so we can use these to format our numeric numbers, our decimal values and integer values, so that they print nicely out to our user interface. Okay, and then this -10, this just means that we're gonna print a string, but we're always going to make sure that it takes up 10 spaces. So the dash here means that it's going to be left justified, and so this is what we get, price with 10 spaces. So if you are trying to line things up, maybe you're trying to make a table on your user interface or something like that, then you can use those %10s or % dash and a number to kind of create columns of data that you want to print out. So we'll see more of that as the course goes on.